All right, my friends, let's go ahead and see how we can get through this problem. So for a problem like this, I would start by drawing that picture of the construction that we did at first. And it's just a sketch, so we're not going to get perfectionistic here. We're just going to, draw it. And then point out, things are congruent to themselves, and then these sides are congruent as well. Okay, so I draw 3 pictures for these problems. Okay, so I draw the master picture, and then I draw a picture of this smaller triangle that's on the left side. I draw that. And then I draw the big outside triangle. That shares. So both of these triangles have the same information, okay? And how did I know that this was going to be a 2-solution case? There are ways, and we'll talk about that after we get through this example. There are ways for you to know based on the given information. But I would say the biggest trigger is that the example said find 2 triangles. Anyway, and I'm going to do that for you on your test. I'm going to say if it's a 2-solution case, I'm going to say find 2. So there you go. That's how that'll go. When you go through your problem set in the homework, you could always follow the lead with, checking your answers in the back. If in the back there's, solutions for 2 triangles, then you knew it was a 2-triangle case. Okay. And again, we'll talk about the real way to tell when it's a 2-solution case. But for now, those are kind of the easiest ways. Okay. Read the directions carefully and make sure you always check your answers in the back. So you should be anyway, right? Okay, so now let's talk about, let's label these triangles. So let's see, A, how do we want this to go? Let's say, where would B go? B is 31. I bet you, it would have to be over here, huh? There we go. Okay, I'm gonna label this other triangle the same way. Notice though that this B value, will be something different. So you could be legalistic and call it B prime because it'll be a little different. And then C would be something a little different as well. There we go. Okay. Otherwise, everything would be the same between the 2 triangles. Okay. So you can label, what's what as well, right? You could say equals 12. B is 31. And A is 20.5. There we go. Okay. Now let's get started. And you're basically going to, for now, just pick one of the pictures that I've labeled up here and kind of set up law of sines type stuff to solve. Okay, and don't worry about which one you're solving for quite yet. It'll work its way out as we go. Okay, so either way, let's try to find a complete ratio. It looks like the A ratio is complete since you have the angle and side length that are opposite each other. So I'm going to set that up. So sine of 20.5 degrees over 12. And then looks like we'd better go for angle B. So I'll just say sine of B over, and then the side length opposite of that is 31. There we go. And then let's just follow our, algebra knows and solve. So cross multiply and divide, and you'll get an expression for sine of B. So it's 31 times sine of 20.5 degrees all over 12. And then what's the next thing we'd have to do to undo sine? That's right, we'll have to take arc sine of both sides. And so we'd get B is the arc sine of this messy expression. Now, as pre-cal students, you want to make sure that even if you have a pretty complex expression like this, that you can enter it all into your calculator without having to stop and copy decimals down and repunch them into your calculator. So, and there are different ways to do it. So for me, I start with 30 times sine of 20.5, making sure you're in degrees mode with your calculator. And then I subtotal it and then divide it by 12. And then I take arcsine of, and I use the answer key, which is the negative key, just push second and then that negative key at the bottom. And there's a more direct way to do it as well, as long as you have a way to just enter it all in and not have to stop and punch buttons in, or stop and copy decimals down. Okay, and it looks like I find out the angle B is approximately 61.106 degrees. Okay, so now I want you to look at your pictures here, and I want you to tell me, looking at the picture on the left here, look at angle B, and look at the picture on the right here, look at angle B prime. Which angle would you say we just solved for, since we got something less than 90 degrees? So I agree. We just solved for B prime. So I actually should probably go up and be like, oops, should have called you B prime this whole time. So there you go. So we're actually solving for this angle over here. And why is it that we didn't get the measure of angle B in the first triangle? Well, it has to do with the range restriction on arcsine. Do you remember how whenever you take arcsine, your answer was always in either quadrant -1 or quadrant +1? So your answer was always between -90 degrees and +90 degrees. Arcsine can never give you an obtuse angle measure, which means that your acute triangle is always going to be the first triangle that you solve. So your acute triangle is always going to be the first triangle that you end up solving for. And then when you're done with it, you could always solve for the second one. I hope that makes sense. Okay. So what we're going to do is finish out the work for triangle 1, and then we'll carry over and talk about how to get to triangle 2. No big deal. Okay. So let's finish out triangle 1. So let's see. We know 2 angle measures, and it would be really easy to get the third just by using the fact that everything adds up to 180 degrees. So let's solve for angle C. We're going to do 180, take away my last answer, and then take away 20.5. And now we know what angle C is. Right, the measure of angle C is approximately, I should say, approximately 98.394, it looks like. There we go. Okay, and what's left for this little acute triangle here? It would be side length C. And so let's just use some law of sines. So let's do sine of 98.394, which I still have sitting on my calculator with all the extra decimally goodness. And then that would be, since I'm using something rounded, I'll say approximately equal to. And I'm going to always go back to the complete ratio that they had before I had any chance to mess anything up. There we go. Solving for C. There we go. So let's calculate that. Sine of answer for that sine of 98 something something times 12 and divided by sine of 20.5. All right, so it looks like we get, for side length C, we get approximately 33.898. And that's a side length, and I think everything was given in meters. This is a very large triangle. Anyway, and then you would have had that as well. So there we go. And we've solved the acute angle, or the acute triangle there on the right. And I hope it makes sense that when you do this, because you used arcsine to get that first angle, you will always be solving for the acute triangle first. Okay, and these pictures should help you keep everything straight. Okay, so now let's look at triangle 2. So getting started on that. That's what this master picture here is for, is to help you keep everything straight there. So in the master picture, when we first found the measure of this angle B prime, which was here, that was this guy right here. So we know that that guy is 61 something something, right? Well, you can see this isosceles triangle here on the right side. So if that one's 61.106, then that one is also 61.106, that angle measure. So it's actually just going to be a little bit of geometry that helps you figure out the measure of this angle right there. So yeah, you could just take 180 and subtract off 61.106. There we go. And so now we know that the measure of that guy is approximately 118.894 degrees. There you go. And it should look right in the sense that, we at least are getting an obtuse angle measure and all that stuff. So I'm going to add that to this picture right here. Oops. There we go. And then, once we know the measure of that angle, you could always just start subtracting the angle measures away from 180. And we'd find the measure of angle C up here to be 40.606 degrees. There you go. And then for this triangle 2, all you'd have to do is solve for side length C. So a little law of sines for that. So sine of 40.606 over side length C would be equal to, or approximately equal to, since that angle is a little rounded, sine of 20.5 degrees over 12, right? 12, yeah. There we go. All right, cross multiply and divide. There we go. Punch it on your calculator. And we end up with approximately 22.302, it looks like, meters. All right, and then I'll just go in and label it on the picture. There we go. All right, looks like we've got both triangles all labeled up that satisfy that given information, that basically fit that 2 side lengths and a non-included angle measure type setup. Okay, now for some folks who at this point are a little kind of weirded out, which happens, like I'll give this to you. I personally do not find this helpful, and everybody's a little different on this. But here's a summary of this ambiguous side-side angle case. And it kind of classifies what type of outcome you could have as far as how many solutions based on how the lengths and angle measures compare to one another. Now, when you look at this setup, I hope this first one, kind of where you get no solutions, I hope that one kind of makes sense that, if the side lengths are not long enough to reach the other lengths and close the triangle out, then you wouldn't have a solution. But what's nice about that is that if you don't notice that you have the right setup for a no solution case, the math will actually tell you, because when you try to take arcsine, for example, your calculator will say error. And so that's your tip off that you had a no solution case. So hopefully that makes sense. And then I hope the rest just kind of makes sense on kind of a draw it construction type level. Okay. But like I mentioned before, when you do this type of problem in a test situation, I will tell you in the directions that you're supposed to find 2 triangles. So hopefully that helps everybody. All right, my friends, I hope the problem set goes well, and I hope you'll ask me questions if it's not going well. Take care, everybody.